Okay, Year 10, we're going to move on to the next exercise, or the next lesson, which is finding the equations of linear functions. Now, finding the equation of a linear function is important because it allows us to then use that equation to find exact future points or previous points. So let's have a look at exercise 5F. Now, there are quite a number of ways you can find the equation of a straight line, and I'm going to show you 3 different methods. But today, in this lesson, we're just going to concentrate on one method, which is the gradient and the y-intercept. If I can find the gradient and the y-intercept, I can write the equation of the line in the form of y equals mx plus b. But remember, we're now using y equals mx plus c. Okay, so let's go down and have a look at these. And we're going to skip a couple of questions. We're going to come back to them later. But we need to have a look at these ones. So I'm not going to do all of them. I'm going to do 1 or 2, and then if you get it, I want you to stop the video, go and do the questions, and then come back and check. So I'm going to do 2A and 2D, and I'm going to have a look at 2C and 2F. But you need to do B and E. So remember, I'm going to be using this, y equals mx plus c, where m is the gradient. If I can find the gradient, I can just find that value and put it in there. And c is the y-intercept. So if I've been given it, it's pretty easy in a line, and I can see where it crosses the y-axis. I've already got one thing. So let's have a look at question number 2A. So 2A, and I'm just going to write, well, this is an equation. It's y equals something x. I'm going to leave a space there to put the gradient in, plus something. And I just have to find those two somethings. Well, if I look here, and I can see straight away, the y-intercept is 4. I'm just drawing that too big. There. The y-intercept is 4. So straight away, I'm going to put a 4 in here. So all I have to do is find the gradient. Now remember, the gradient is the slope. So the slope is just the rise over the run. So if I can draw a right-angled triangle, and this is the rise, and this is the run. Well, the value, what is it? What is the value from here to here? Oh, well, that's 4. And what is the value from here to here? Well, that's 2. So the gradient is 4 over 2. So m equals 4 over 2, which equals 2. So I go back and I write 2. And the equation is 2x plus 4. Now, are we doing 5 or 4? No question, exercise 2. No, they're just asking us to find the gradient. Oh, I found the equation on the line. We're going to come up against it. So I'm going to do the same here. Remember, we're just trying to find the gradient here. So I've gone too far in that. They just wanted me to find the 2. So 2b. Again, all I have to do is draw a right angle triangle. And it doesn't matter where I draw it. So I could draw it here, or I could draw it here. And as long as I know the rise over the run. So here it goes up to that point there, 4, and it goes across. Well, how far across has it gone? Well, that's about, I reckon it's gone across 1. So, and if I did it down here, 4, over 1. They've given us the coordinates, so we know that. So the rise is 4 over 1, and that's going to be the gradient. But this line is going down, so it's negative. So m equals -4. Now, you do the same for these two. One's going up, it's going to be positive. One's going down, it's going to be negative. These two here are interesting. This one is a flat line, so it has a gradient of 0. This one is a vertical line, so it doesn't have a gradient. Its gradient is infinity. All right, let's move on. So you have a go at 2B and C, B and E. We're skipping through. We're going to come back to that. Righto, here's what I should have been doing first. Let's find the equation of these lines. We already know how to do it. Again, we're going to use y equals mx plus c. And I'm going to do A, D, and E. I'll leave you to do the other one, see how you go. So, here's for A. Y equals something x plus something. Well, the first something I need is the y-intercept, and that is 3. So y equals something x plus 3. Now I have to find the gradient. So I'm going to zoom in here. I'm going to draw, now they've given me 2 points, which is very good. I'm going to draw my triangle there. Now this is positive, so how far across does it go? Well, it goes from 0 all the way to 5, so it goes 5 across, 0 to 5. And how far up does it go? Well, it goes from 3 to 8. So here it's 3 and it goes all the way up to 8. So that's also 5. So the rise over the run, the gradient, is 5 over 5, which equals 1. And it's positive. So it's just a positive 1. Now I don't need to write the 1 in there, but I'm going to anyway. So y equals 1x plus 3, or just x plus 3. So you have a look at B. What's the y-intercept? It's a positive line, so it's a positive gradient, and draw yourself a triangle. Can I suggest, here's a nice little triangle, you go there. Or you could go there. It doesn't matter which one you use, you'll still get the same gradient. Might even do that really quickly for you. The gradient here, it goes across 2 and up 2, so 2 on 2, which will be a gradient of 1. Here, it goes across 3 and up 3, so 3 on 3, oh, that'll be a gradient of 1 as well. Okay. Now, I'm going to go down here. Let's have a look at this one. First of all, what's the y-intercept? Give me back my pen, thank you. Well, the y-intercept is 4. So let's go back. And this is 4. Come on, give me a black pen. I want black, thank you. 4D. And it's y equals something x plus 4. Okay, let's have a look at the rise over the run here. So I'm going to draw a nice little triangle. I've got a nice one. Oh, geez. Let's get rid of all that. Nice little triangle here, from there to there. It doesn't matter where I draw it. I could have drawn it all the way down to there, but I'm just going to use this one because it's on the axis. It's nice and easy. So it's 4 over, oh no, well I can't use that point, can I? Because I don't know what it goes through. So I will have to use this one, because I don't know that value there. Righto. So how far is this distance? Well, it goes from -2 up to 4, so that's 6. And this distance is 2. So the gradient is 6 over 2. But hold on, it's going down. So it's negative 6 over 2, which is negative 3. So go back and put a negative 3 in front of the x. So negative 3x plus 4. Okay, so this is pretty easy. And as soon as you know the gradient and the y-intercept, you've got an equation. This one here, this one has a 0 gradient. And it's just a straight line. And when you get a horizontal line or a vertical line, it's either x equals or y equals. So this one is just y equals 4. It doesn't matter what the x value is. What's the x value there? 4. What's the y value? 4. What's the x value there? 2. What's the y value? 4. What's the x value here? Negative 2. What's the y value? 4. What's the x value here? Negative 4. What's the y value? 4. Y equals 4. Okay. So you have a go at B, C, and F. Remember, if it's going up, it's got to have a positive gradient, and if it's going down, it's got to have a negative gradient. And the y-intercept is pretty easy. The other one that we have to do is question 5. Now here they haven't given us, the grids on the x and y axis, but we don't need them. So again, I'll do A, D, and E. Now the problem is they haven't given us the y-intercept. All right, they haven't given us the y-intercept, but I'm going to show you how to find that using the equation. So y equals mx plus c. Okay, so the first thing, I'm going to draw a triangle. Now, if I zoom in here, how far across does it go? Well, it goes from 2, because the x value is 2, and the x value of that next point is 5. So 2 to 5 is 3. You can, if you want, and I need you to start thinking this, 5 minus 2 equals 3. Now, how far does it go here? Well, it goes from the y value of 8 up to the y value of 14. And you can count that up and go 8 to 14 is 6, or you can just go 14 minus 8, and that equals 6. So I've got 6 on 3. So the gradient here, the rise, and it's positive, is 6 over 3, which is 2. So I go over here, and I write, okay, y equals 2x plus c. And I don't know what the c value is, but what I'm very fortunate in is that they've given me 2 sets of coordinates. They've given me 5 and 14 and 2 and 8. So I'm just going to sub in 2 and 8. And remember, the first value is your x value, and the second value is your y value. So if I put them in, I should be able to write an equation and find c. So 8 equals 2 times 2 plus c. 8 equals 4 plus c. Subtract the 4. 4 equals c. So my equation is y equals 2x plus 4. Now, it wouldn't have mattered if I substituted in the other value. The other value is 5 and 14. And if I did that, watch what happens. 14 equals 2 times 5 plus c. 14 equals 10 plus c. 4 equals c. It doesn't matter which point you sub in, you will still get the same value for c. Let's have a go at another one. Remember, I'm going to do this one that's going down. So I'm going to do this one here. Now, some people are already getting really fast at this and working out, the easiest way to find out the rise over the run is to subtract the y values and to subtract the x values. Because here I'm going from 2 up to 6, and 6 minus 2 is 4. And here I'm going from 3 to 5, and 5 minus 3 is 2. So the gradient here is m equals 4 on 2. But remember, it's going down, so it's negative. And 4 divided by 2 is 2, so the gradient is negative 2. So if I come back here, and that was 5a, and this is 5d, y equals mx plus c. We worked out the gradient was negative 2x plus c. Now I just have to sub in one of the points. Well, which point will I sub in? Always choose the easiest one. I'm going to go 3 and 6. So I'm going to sub in 3 and 6. It doesn't matter which one. They're not particularly harder than each other. And remember, that's your x and that's your y. So 6 equals negative 2 times 3 plus c. 6 equals negative 6 plus c. Add the 6 over, 12 equals c. So y equals negative 2x plus 12. Now here's an important point. When you get an answer like this, you go back and have a look at it and go, well, that 12 is meant to be the y-intercept, which is where it would cut that's an awful big line. It's where it would cut somewhere around there. Now, does that value look like 12? Well, if that's 6, from there to there is 6, yeah, that's pretty close. I feel happy with that. It's not 100% right. This diagram is not to scale. Okay, the last one, E, and I want you to do F on your own. So again, draw yourself a little triangle. Go and have a go at it yourself if you want. And here you're going from negative 7 to negative 10. So negative 7 to negative 10. If you subtracted those, you would get 3. All right, negative 7 minus negative 10. This distance, it's going from 1 to 2. Well, 2 minus 1, or 1 minus 2 is 1. So the gradient is 3 over 1. But again, it's going down. So it's negative 3. So I go over here, and this is 5e, and I write y equals negative, let's write mx plus c first, mx plus c, so y equals negative 3x plus c. Now I have to substitute in one of these values, which is going to be easier. I think 1 and negative 7. So 1 and negative 7. Remember, that's your x and that's your y. So negative 7 equals 3 times negative 1 plus c. Negative 7 equals negative 3. Hold on, it's not negative 1. It's just 1 plus c. I've got to subtract that negative 3. So negative 10. Oh, sorry, it was a negative 3. It's negative 3 times that. So go back, because it was a negative 3. I've got to add that 3 over. And if I add that 3 over, I would have got negative 4 equals c. Now I'm just going to go back and have a look, because I already knew that I'd made those mistakes as I was going along, because I knew where the line was, and that value there has to be negative 4. And when I got negative 10, I went in my head, that doesn't look right. And that's when I picked up that I'd made a mistake with the negative. So knowing what you're doing plays an important role. So therefore, y equals negative 3x. You can write plus negative 4, or you can just go y equals negative 3x minus 4. Now, you need to finish 4 and 5. You've got 3 to do. You've got B, C and F. Find the equations of those lines. And in 4, I'm pretty sure it was B, C and F as well. Good luck.